All right, so matrices. A matrix is a container. It contains numbers. I mean, it can contain anything. Wherever you talk about computers, a lot of times they use matrices to contain strings and other things. Strings are just a bunch of letters. But in here, we're going to contain numbers in them. It can contain any amount of numbers you want to. Just to start defining it, I'm going to do this. But usually whenever we define a matrix, we start defining it like this. Oh, that should be 1, 1. Okay, so I messed that one up. Let's start that over again. That's kind of how they do a generic matrix. You're not going to be asked to do anything like that. I just wanted to show you. Okay, going sideways, those are called rows. Up and down, are columns. I know, this is fancy. Again, I don't know. Some of you have had some matrices. Some of you have had none at all. In Algebra 1, they're supposed to teach you some matrices. Okay. Now, what we're going to be working with today are called augmented matrices. What we're going to do is we're going to take equations and put them into matrices and use the matrix to solve an equation. Yeah? Yeah, we had time at the end of first semester to do this. We didn't this year because they shortened the semesters. Okay, what an augmented matrix is we're going to take that information and we're going to put it inside of a matrix. So we have one column that represents the x coefficients. We have one column that represents the y coefficients. Then we put a line in, and on the other side, so this line represents the equal sign. And then on the other side of the line, we put the values on the other side of the equal sign. That's an augmented matrix. Yeah?
What would you put in the sign? So x p times by y, or equal the like number? How does that work out?
No, nothing's being done anywhere. I just took my equation and turned it into a matrix.
Okay.
So right here, this row represents the first equation. This row represents the second equation. So there's nothing I'm doing with it. I'll show you what we're going to do with it here in a second. There's lots of different things you can do with augmented matrices. It's just what we're doing is we're taking equations and we're turning them into matrices. The whole idea of this is really the use of computers and calculators. We want to be able to take these things that we do by hand and we want to be able to put them into a system so it can do it for us. Once we turn them into matrices, the steps are repetitious, right? Whenever we're solving a system of equations, the steps you do are the same every single time for every single problem, right? If we turn it into something like this is something we can input into a computer, and then the computer can do it for us because the computer understands matrices. So that's what we're learning about. That's the point of matrices. Then wherever you get up into higher level math, there's math programs where you can program them to handle matrices different ways. Okay, now we're going to start talking about row operations. What row operations are the same thing as solving a system of equations. Anything you did wherever you solved the system of equations, you can do with row operations. We're just doing them in a matrix format instead of using the equations. So, one thing you can do with a row operation, and I'm just going to use this to show you. One type of row operation is you can switch rows. Dang it. If I could actually write it correctly. Ah. Okay, that's better. So you can switch rows. I can take the bottom row, move it to the top, and the top row, move it to the bottom. That's one row operation. That one's not the most useful for what we're doing today. Okay, we can multiply a row by a constant. So if I want to, I can take this top row, and a lot of times the way I'm going to write it is I'll say I'm going to take row 1 times 2.
What do you mean by constant?
A constant is just a number, no variables. I could do both of them if I wanted to. Doesn't matter. You can multiply any row by a constant.
I mean, like you can do one without doing the other.
Yes. Or you can do both of them.
But
Yeah.
if you're doing that, you need to show R1 times 2.
You want to show your work so that you don't get lost. That way, if you make a mistake, you can go back and see what you've done. You can add or subtract rows. So let's say I want to take row 1 plus row 2. Now, whenever I do this, I have to have some place to put the result, correct? Well, I only have 2 rows. So what I have to do is I have to replace one of my rows with the answer. So I'm going to say that I'm going to replace row 2 with the result. So I take row 1 plus row 2, and I'm going to put the result inside of row 2. So 2 plus 3 is 5. 3 plus negative 5 is negative 2. 10 plus 7 is 17. So like wherever you have systems of equations, you add the two equations together and you get a new equation, right? Now, the point of doing that is we always do that to eliminate a variable, which we'll get to that. But with a matrix, we have limited space. So in order to do that, whenever I get a new equation, I have to eliminate an old equation. So I have to actually delete one of my old equations to insert my new equation. Yeah, I only have to get rid of one equation. But whenever you do that, you have to get rid of one. Now, we'll have a method to this, and I'll show you how to do this. But whenever we add them together, I have to replace one of them. Just like up here, whenever I multiplied by 2, I didn't keep the old row. I actually had to replace it. Okay, so those are our row operations. So we're going to use all this, and what we're going to do is we're going to solve systems of equations. And you might go, well, okay, isn't it just easier to take this and solve it by hand? And yes, it is. That's not the point. The point is to learn row operations. That way you can, if you get into something eventually where you're going to have to program a computer to do it, you know the row operations and the method so that you can tell a computer how to do it. Or whenever you have to take linear algebra, you know what row operations are so that you can do it. That way this isn't brand new wherever you hit college. Okay, so this is what your problems are going to look like. You're going to be asked to solve for x, y, and z using row operations. Now, it's very important that you understand everything that we do from here on is the exact same as what you would do solving by elimination. All we're doing is solving by elimination. We're just doing it inside of a matrix. So the first step here is to create our augmented matrix. So we take our x coefficients, so 1, -1, and 2. We take our y coefficients, 2, 3, -5. Our z coefficients. Now, if a z is not there, that means its coefficient is 0. Put the line for our equal sign, and then we have 9, -4, 17. Yeah.
For the second equation, do you need to put a 0 there?
Yes. Okay, now, what we're going to do is we're going to use elimination, but we're going to do this very specifically. What we're headed towards, and it's easier if you know what you're headed towards. What we want is we want to get to where we have numbers here. And then zeros here. Now, what this is like eliminating your x values and then eliminating your y values. So what I want to do is I want to look at this and say, okay, I want to eliminate, I'm looking at these two equations. I want to get rid of the x value. So again, these two equations, I want to get rid of the x value. Do I need to multiply them by anything? I just add them together. So I'm going to take row 1 plus row 2. And I'm going to put that inside of row 2. So again, it's just like taking the first two equations, adding them together to get rid of the x value. It's just I no longer get to hold on to my second equation. It disappears now. So, first row stays how it is. Third row stays how it is. Now, you could, once you get used to this, you could do multiple operations at a time to save space. I just want to do one at a time here to make sure that we're getting this. All right, so I'm adding these two together. So 1 plus negative 1 is 0. Negative 2 plus 3 is 1. 3 plus 0 is 3. 9 plus negative 4 is 5. Right? Whenever we do systems of equations, we always eliminate one variable twice, correct? So I'm going to get rid of my x value twice. So now I have these two equations, the x and the 2x. What do I need to do? Multiply the top equation by negative 2, and then add it to the last one. And I'm going to replace the last equation because I want a 0 right here, correct? So I'm going to replace the last row with that. So negative 2 times 1 is negative 2 plus 2. Actually, here, before I do that, let me write down everything else first. Nope. Okay, so negative 2 times 1 is negative 2 plus 2 is 0. Although I think I know what you're talking about. Okay, negative 2 times negative 2 is 4 plus negative 5 is negative 1. Negative 2 times 3 is negative 6 plus 5 is negative 1. Negative 2 times 9 is negative 18 plus 17 is negative 1.
We're completely ignoring the second row.
Yep, didn't use it because this says I'm taking negative 2 times row 1 plus row 3. So the second row isn't part of this at all. I could, but why? Nope, don't need to. All that's going to do is make my numbers bigger up there. And then if I needed to use that top row again, I would have to divide all those numbers back off. Oh, sorry. I'm hiding. Oh. Thank you. I was listening to the beginning of the
Oh, we did have. Can we go now?
Yeah, go. You're supposed to be there already. Here, just a second. You won't be back. I mean, you can hide it in the corner if you want to, but okay. Now we have one more step to do because we still need a 0 right here. Now, I do not want to use the top row again. Why do I not want to use the top row? Now, if I use the top row, that's going to put a 1 back in this spot. So that's going to eliminate that 0. So you need to use the second row now. So I think that's kind of what John was talking about. Whenever, after you use this, you do not want to go back and use it again. I don't know. Ignore it, John. After a certain point, you do not want to use a row again. So now we want to use the second row. Okay, I have a 1 and a negative 1. So do I need to multiply by anything? Nope, just add them together. So row 2 plus row 3 equals, and I'm going to insert that into row 3. Row 1 is not being touched, so I'm just going to write it down. Row 2 isn't really being touched, so I'm just going to write it down. Row 3 is now going to be 0. 1 plus negative 1 is 0. 3 plus negative 1 is 2. 5 plus negative 1 is 4. Okay. Now, I told you that's where we wanted to get to. Now, I could actually solve this entire problem just using matrices. It just takes a lot longer. We can actually use this and get our answers now. If I take equations and put them into a matrix, I can take a matrix and turn it back into equations. So what 3 equations do I have now? Okay, so what's Z? Okay, so Z is 2. Oops. I can plug that into here. No, not -6. So there's my X, Y, and Z. Yep. So any of those equations you plug it back into, you should get the same thing. So 2 times 1 minus 5 times -1 plus 5 times 2. That's 2 plus 5 plus 10 is 17. So that works. -1 plus 3 times -1, that's -4, so that works. The last one definitely works because that's the one I used to find X. All right, because of the length of time it takes to do one of these, I was just planning on doing one. Are you guys okay with that? Let me double check that real quick. Okay, wait a minute, that's not right. What the heck? Okay. There, do that instead. Sorry. Hmm?